Hi, this is Shadi Atia, professor at Liège University in Belgium, and today's presentation is about operationalization in observational research. Well, this presentation is part of a playlist on observational research. I invite you to watch previous videos to position yourself. Now, I need to remind you that we are talking here about how to operationalize your research within the family of observational research, where we are trying to focus on non-manipulative research. So it's the study design that typically represents realistic conditions. Well, the objective or the audience of today's presentation is mainly researchers who are conducting quantitative research based on observations. They are doing correlational research, in other words, and the lecture is helpful for researchers preparing a research thesis, dissertation, a conference paper, or a journal article using observational research methodology. The objective of today's presentation is enhancing your capacity to conceptualize, design, and conduct observational research, and to formalize an appropriate research strategy and study design based on best practices. So I'm going to start with defining operationalization, talking about the main concepts and variables that you need to define for your study, what is the null hypothesis, the measurement protocol that you have to develop and adhere to, and the testing and validation of your observational tests, before some takeaway messages. So let's start with operationalization. Well, operationalization is the process of transforming your concepts into indicators that you can measure or observe. And here we start first transforming the general context of your research and the concepts that you want to address into specific measurable indicators. When we look at operationalization, where is it positioned within the research agenda, we can see that we need first to start with defining our research problem, then we come up with general research questions, then we can develop our conceptual framework, theoretical conceptual framework, and here then after just that we can start operationalization. But keep in mind that after operationalization we will revisit our research questions and then we start thoroughly designing and developing and planning our research design before starting the data collection process. So operationalization is part of every research process, and it is the transition from theory to empirical research, as you can see. So we start always with the general research questions, investigating the problem, the context, and then we start the operationalization. And with operationalization, we funnel down our research scope, we sharpen our research questions, and as you can see, we start with broad questions, then we narrow down, we focus in, and the operational process starts before coming with a specific indicators and variables that we want to investigate, and then we can start only after that start our observations and the data collection process and so on with analysis and testing. So in this context, it's very important to understand that operationalization is a quality measure in order to make our research more focused, sharp focused, and specific. As you can see, why is it important? Because actually we start our research with general concepts when we start our design, and then we need to do the operationalization in order to translate these concepts into variables, into indicators that can be measured, and also define the protocols and the standards that we will use in order to measure these indicators and these variables. Only then we are ready for the data collection step. Now, this is the first introduction. Let's talk about the concepts and the variables that will be we are concerned with in our research. As you can see, in order to define your research question, you need first to define your research goal. So one of the major steps that you have to start with is to identify the methods of observation to be used, and it might involve the following. It might involve answering the following question. Why are you interested in observing a sample group? This is a question. What is the scope of your observation? And what ethical concerns may affect your study? So it's very important to answer those three questions in order to be able to come up with a research question and indicators that can be later on observed and measured. Now, when we look at general research questions, as you can see, we previously talked in a lecture about research questions. I invite you to watch it, but the most important takeaway message from there was that research question needs to be clear and focused. They need to include the what, the how, the why, and it's always recommended to start with questions related to how or to what extent. Also, the research question needs to be avoiding any broad or general or generic formulation. You need to choose questions that avoid closed-ended answers like yes or no. You need always to ask open-ended question, and you need to include in your questionnaire formulation or in the articulation of your question the variables that you want to observe or that you want to measure or you want to correlate, and it requires to have analytical, rather descriptive research questions. So try to avoid the questions that are on the side of describing the problem or describing the phenomena, and try to focus on questions that are more on the correlation or on the causation, if possible. Is there a link between, or how to establish the link, or to what extent there is a correlation between, or can we influence such or such parameters. So these are the high quality questions that are specific. They include variables, they are open-ended, starting with to what extent, and for sure they are correlational or looking to relationships or causation. Now, when we look at operationalization and where is it positioned in this process of research design, as you can see, you need to start first with your literature review. You can do an initial literature review. You will start to define your variables. You will determine what variables can be measured for each concept, and then you can determine how each variable can be measured. From there, you can move to the next step, step 4, to choosing your variable, and here you will be more conscious about the choice of your observations based on the possibilities and the availability to measure and the pragmatic feasibility of the measurement. Now, it's very important when we talk about observational research that we are more here focused about indicators. It's less that we focus on variables, because in variables, the researchers has to control over them. They are intentionally changed to see the effect on the dependent variable. And as you know, we mentioned in the previous lecture that in observational research, you are using non-manipulative approaches, so you are not changing the conditions. You are in natural condition or natural environment, and you are observing and trying to establish correlations through statistical analysis. So in this sense, we are very focused on the indicators that are measuring the response to an independent variable, and we can also rely on sub-variables that are measured, or they can measuring the response to the independent variable. So it's important to take this into account compared to experimental research, where we can manipulate the independent variable. Here we are mainly focused on the dependent variables. Now, operationalization is a step of research design that cannot be missed. So it allows you to find procedures to measure and manipulate variables. It allows you to translate abstract concepts into more concrete variables. And don't forget that operationalization is a translation work. So simply you are translating the concept or your abstract concept and theoretical aspect into concrete variables that can be measured in general. Now, the concepts must be captured as much as direct as possible, and you must make sure that there are measuring units for these variables or for these indicators, and there is a protocol for that. Now, before continuing with our operationalization work, we need always to define our null hypothesis. So what is a null hypothesis? Well, actually, when we do research, we will most of the time, we will have a sample population that we are trying to observe, because it's very difficult to observe the whole population. And then we will have a real population. So actually, we have a real population that is large, and then we have a smaller sample that we are observing. So the hypothesis here, what we need to do with the null hypothesis, that we are trying to probe that something is more extreme than what we observe. So what we try to here to see that we start our observation, we calculate our sample mean, and then we start to estimate the real population mean, and we start to see if there is an unknown population mean and start to compare them. So actually what we do, let's take an example. We have a real population, and this population has a risk of heart attacks, and we are trying to ask the question, does the risk of a heart attack reduce by daily intake of aspirin? Can we reduce it? This is on the large population. And we have here a small sample of people that we started to observe, and we are asking ourselves, a heart attack is not affected by the daily dose of aspirin. So how to check this hypothesis? So first thing, I want to know if my sample mean is a good mean estimate of the unknown real population mean. So I can calculate my sample mean because I collected the data about my sample, but I don't know what is the real population mean. So in this sense, I will calculate it. Then for each test, I must provide evidence against the null hypothesis. So I will hypothesize that if the real true mean and compare it with the value that I observe, and if the result difference is null, then I reject the hypothesis in this case, or I can go with power statistical testing. But what we can observe here is that we always start to calculate our sample mean, we estimate a real population mean, and we compare both of them. If they are matching, then we can say that aspirin has no potential of reducing the risk of heart attack. If we find a difference, then we don't have a null hypothesis, then our hypothesis is valid. So this is how it works when we operate or when we start to investigate the null hypothesis. Always I have my sample, I get my mean of my sample, I assume a mean for the larger population, and I always conduct a mathematical calculation to distinguish the difference between my mean and the mean of the real population that I estimated, and if they are equal, then I'm reaching a null hypothesis. If not, then my hypothesis has a potential to be true. Now, operationalization here is very important because I need to set up my null hypothesis or my research question that is hypothetically setting the boundary condition for my research. So after finding several ways of operationalization, the concept needs to be translated into variables, and the data collection should start while keeping in mind the following criteria. First, we need to make sure what are our indicators, what are the sub-variables, and what are the variables of our study. We need to make into account that we will conduct analysis of variance. If the analysis of variance shows a significant or remarkable variance, then we can move on with starting measuring or establishing an association or even a correlation in a positive sense or a negative sense. And if we created an association or a correlation, only then we can proceed with our statistical testing, moving to a regression if there is a real association or correlation. And maybe if we are lucky, we can go on with examining the causality or the cause effect. So these are the statistical steps that will take place, and it's not always sure that we will reach the causality. Sometimes we stop if I don't find a variance. First of all, if I have a null hypothesis, I have to stop my work. So this means that the mean of my sample is equal to the mean of the real population, meaning that my hypothesis is not true. So there is no need to further continue my investigation. But if the hypothesis is not null, then I can continue. Same approach with variance. If there is no variance between the samples I'm comparing, then there is no meaning to continue. So it's very important to understand that when we do statistical tests in observational research, we go step by step, and depending on the result, we proceed. Now, it's important to take into account that the hypothesis predicts variance, association, or correlation that must be tested after the data collection process. So chosen variables must be tested for correlation that might lead to regression relation. So this is the main conditions to proceed with our observations and with our statistical tests. Now let's move to the following point of our presentation, measurement protocol. How to proceed with our measurement protocol. Once we defined our concepts, we translated them into indicators, and once we came with the null hypothesis that defines the frame of our work, it's now time to get busy with our measurement protocol. How I'm going to conduct my observations, what are the standards or the protocols that I'm going to rely on. So first of all, just to remind you and refresh your memory, I need first to understand distinguish if I'm working on primary quantitative data collection methods or I'm working on secondary quantitative data collection methods. If I'm working on primary quantitative data collection methods, as you can see, then I'm either doing observations through mechanical approaches using devices and technology, or I'm doing it through humans. So I'm using surveys with questionnaires that are conducted, or through interviews. If I'm not using primary quantitative data and I'm using secondary quantitative data, meaning that I'm relying on existing data sets that are available online or through reports or physical documents, in this case I'm using secondary quantitative data. So it's very important before moving on and defining the protocol and the standard of data collection, I ask myself, is the data primary, I'm going to collect it myself, or it's secondary, it's already existing and I'm going to collect it from the literature and what is available in the state of the art. If I have the data already secondary, then there is no mean to have measurement protocol. I need to verify how this data or this secondary data was collected and make sure that the protocols and the standards used to generate this data is appropriate and well documented and are complying with best practices and best state of the art on the data collection. If not, then it will be primary quantitative data that I am going to collect myself, and in this sense I need to know it's mechanical or human. Now, when we look at any field on any research domain of investigation, once I'm doing observational research and once I'm going to collect data, I need to have a history of protocols that for studies before me. So before running an observation, it's important to gather information about the history of similar measurements. Who did such studies before me? How did they collect data? Have the similar measurement have been performed before or not? What for? What was the setting of these measurements? And I need to conduct a literature review related to the research topic. So here I have to provide better knowledge about the research topic. It will allow me to provide a better understanding of the research question and the hypothesis, and it will provide insights on the past observation performed in this field. So instead of starting from scratch, inventing the wheel, I can already understand what is the history of protocols and standards that try to measure or conduct observations in this area. So the measurement protocol is very important because to operationalize your research and determine the study indicator that will be measured, researchers should seek to comply with normative standards. And in this sense, protocols that can be allowing you to use common terms, common definition, common procedures, common indicators, common metrics and units of measurement, and for sure allow you to have a more consistent observation measurement. Also, it's important to comply with the standardized methods and approaches based on the your research community are working on. For example, if in your research community there is a way to collect the data or conduct the observation, it is the moment to start to get familiar with these protocols or ISO standards or European standards or non-European, whatever country you are based. If in your country or is in your field, there is standards to collect the data and to define these indicators. So it's important to take this into account and to be familiar with these protocols and these standards that allow you to better observe your phenomena and measure your indicator. This is the step that needs to be taken up. This allows you now to move to the last part of our presentation of today, testing and validation. Now, I need to take into account that once I'm starting to operationalize my research, I need to take in my background of my head, think about how I'm going to validate and test this data. So as I told you, when we do statistical analysis, what we are looking at in any data set, it's either variance, correlation, association, we are looking at causation, we are looking at regression. Afterwards, if there's a correlation. So after finding several ways of operationalization, the concept needs to be translated into variables, and the data collection should start with the following. I need first to test my sampling techniques and check what are the measures of location, for example. I need to run some basic statistical tests on the mean, on the maximum, on the minimum, on the variance, and start to check if there's any potential of variance, if there's any correlation. I have to check if there is a potential for association very fast at the beginning. I need to examine the validity of my research questions and that they make sense and they can result into useful output. And therefore, the hypothesis predicts a variance or association or correlation or causation, like we said, and I need to test that early on to make sure that there is a chance of success. Now, there are two key statistical tests that are conducted that we are all familiar with. One is called descriptive statistics, and here we are talking about descriptive analytics. That is a process of using data to identify the general trends and the general relationships within a sample of observations, and we have the inferential statistics, or it's called also parametric statistics, and here we are going much deeper. We are trying to have inferential analysis that is used to measure the reliability of the conclusion about a sample or of a population. Like I said, we are measuring here more specific comparison of our observation with other aspects. We are looking at variance, we're looking at association if possible, if you're looking at correlation if possible, we are looking at causation if possible. So here the parametric or the inferential is more advanced, and we can see the t-test, the chi-square test, the ANOVA test, and the regression test. Those are all famous tests in our approach. So we need to define when we are doing our operational research, what kind of test I'm going to conduct. Am I going to stop with descriptive statistics? Am I going to work on inferential or parametric statistics? What kind of tests are more suitable? What I'm seeking actually, I'm looking at variance, I'm looking at correlation, I'm looking to causation. All that needs to be done early on. I'm sure you are not 100% certain that this will work, because still we didn't start the data collection, but you need to have an imagination, you need to have a plan, you need to have a direction where you are going early on before even starting the data collection process, so that you don't get lost and you don't waste time. Now, as part of the testing and validation, you need to do many other steps. You need to narrow down your research question. So operationalization should lead to narrowing the scope of your research questions. And when the concepts are translated into variables and sub-variables and indicator that can be measured, then the research question can be more specific. This is the end of today's presentation. Some takeaway messages before I can leave you. Operationalization, a very important step. It comes after that we defined our research questions and that we defined our literature review, and we have already some concepts and variables we are working on, and we have a theoretical relation framework for our study. Now it's time we want to operationalize in order to come with the final specific research question and start the data collection. So operationalization is positioned in this step number 7. It's important to some takeaway message to understand that in order to do the operationalization, I need first to define my study variables and my indicators. What will be the independent and the dependent variables of my study? What will be my operationalization steps that I need to take care of? Defining the concept that can be translated into measurable sub-variables or indicators. And this is important so that you don't forget that operationalization is simply we are transitioning from theory to empirical research. Also, you need to establish a protocol and the methods to measure these variables. Don't forget to think about it. Check the history of measurement and history of protocols, how others did it before you, and then check what would be the best way to measure it yourself. You need also to redefine the research question and narrow its scope. This is a result of your operationalization. So once researchers come to my lab and they check with me, I check with them their research questions, or I check with them their research proposal. One first thing I can directly distinguish, I tell them, you did not operationalize your research questions, because I see most of the time very vague research questions, general research questions, closed-ended research questions. They are not including any variables, they are not specific, they are general, they are theoretical, and these are all indicators that the researcher did not go through the operationalization exercise. So it's so important to do it as a way to validate your research question, and for sure you need to choose the correlated variables to perform your observation, to have an idea, okay, most probably I'm trying to measure the variance between this parameter and that parameter, or I'm trying to measure a correlation or an association between X parameter and Y parameter. So you need to have already an idea before conducting your measurements and before your data collection process, what will be the relations that you are trying to measure. Is it a comparison? Is it variance? Is it correlation, causation, and so on? By that, this is the end of today's presentation. This presentation is a part of a playlist on observational research. I invite you to watch following videos, because we will get deeper and deeper until we finish the whole playlist on observational research. Today's presentation was about operationalization in observation research. Thank you very much for your attention.